Hello children, welcome to aimstoday YouTube channel. Here we are going with aims in your live sessions. In this it is about chemistry subject. From this we are going to learn about the chapter matter. It is one of the basic and the fundamental chapters of chemistry. So whatever you want to learn in the chemistry, first let us come from matter and dissolve, with which it is made up of, what are different forms of matter, which it is made up of, how these particles are arranged in the matter, based upon the arrangements, how they are classified, what are the chemical compositions of matter, based upon the chemical composition, how matter is classified. So we are going to learn these all concepts about matter. So here we go with matter chapter. What is the nature of this matter? Matter is anything that has mass and occupies a space and can be perceived by our senses. Matter exists in many forms. Yes, what did we define here? Matter means matter is anything which has some mass and occupies some volume and can be perceived by our senses. That thing, whatever it is called matter. To say about matter clearly, this whole universe is made up of only two things. One it is matter, the other one is energy. So here, energy in the sense it might be light energy, sound energy, electrical energy, magnetic energy, and heat energy. In the different forms, energy is existing. So about these all different forms of energies, we will learn in physics subject. Now, the other thing other than energy is matter. Matter, the remaining all the things are coming under matter. What did we say matter means? That is anything which has certain mass and occupying some volume or place and can be perceived by our senses. Our senses like by touching, by feeling, by weighing, by tasting. So with these all senses, if we are able to observe certain things and which are having mass and volume, they can be considered as matter. See here, different forms of matter are given. Water we can see, the ice we can see and we can feel it with coolness. The water or steam we can see and we can feel its hotness. And volcanoes, magma, stones, some metals like gold, air, these all will come under matter because these all are having certain mass and occupying some volume and can be perceived by our senses. Hence, these all come under matter. As we look at our surroundings, we see a large variety of things with different shapes, sizes, and textures. See here, some examples of the matter are given: milk, coke with bottle, bell, balloons, fruits, books, balloons, pens. These all come under matter. How do we say as these all coming under matter? If you see here, I am telling this pen is a matter. Can we agree for that? Yes, because what do we say the three properties to be a matter? We should have some mass. Yes, this pen is having certain mass. And it should occupy some place or space. Yes, it is occupying. And it can be perceived by our senses. Yes, we can touch it, we can weigh it, we can write with that. So, pen is a matter. In the same way, these all also come under matter as they have these properties. Everything in the universe is made up of material which scientists have named as matter. The air we breathe, the food we eat, stones, clouds, stars, plants and animals, even a small drop of water or a particle of sand, each thing is a matter. So these many kinds of things are there. So all the things which are around us are coming under matter. So how can we classify these? So all the matter we cannot say all the same kind. So we have to segregate them to understand about them better. So that you will see here in classification of matter. As there are so many kinds of matter, a scientific study of matter becomes easier if we classify matter based on some characteristics. Yes, if you want to study about the matter, you want to know the science of matter, it is better to classify these matters based upon certain characteristics. Then, based upon the categorization, we can understand the properties of these matters in the easy manner. Matter can be classified based on two factors. Yes, based upon two factors, matter can be classified. What are those? Physical classification. Another one is chemical classification. Based upon these two factors, we can classify the matter. See, here it is shown full chart for classification of matter. One it is physical classification, the other one is chemical classification. Based upon the physical classification, nothing but based upon the type of particles existing in the matter, based upon the arrangement of particles in the matter. Matter can be classified into different forms like shown here: solids, liquids, gases, plasma, and Bose-Einstein. These all classification come under physical classification, that is based upon the arrangement of molecules in the matter or the particles arrangement in the matter. This is a physical classification. Next one is chemical classification. Based upon the purity of matter, based upon the type of particles existing in the matter, matter is classified into pure substances and impure substances or mixtures. So this is a chemical classification. First, let us go through the physical classification. Physical classification of matter. Matter is composed of extremely small particles. Yes, we know that. Based on the arrangement of these particles, matter is mainly divided into three types. What are the three types, children? They are solids, liquids, and gases. Yes, they are the majorly classified states of matter. Of course, as we said, five states of matter, but broadly we discuss about first these three. Later we can let us see those two special two types also. First, the three states of matter which are mostly existing in our surroundings are solid state, liquid state, and gaseous state. Let us see about these one by one. First among them is solid state of matter. In solids, the molecules are closely packed. Their positions are almost fixed. Yes, in solids, molecules are very tightly packed. They are tightly bounded one to another. You can say simply in our language, they have much strong friendship between the particles. So their molecules have high strong friendship. So they'll be always close one to other. They won't move here and here. So their positions are almost fixed in solids. See, some examples of solids are shown here: wax, stones, crystals, ice, some tools which we use generally, fruits. These all will come under solids. In these all, particles are tightly packed one to another. So what are the properties of these solids based upon this arrangement of particles? Let us see. General properties of solids. Solids have fixed shape. As particles are tightly bound one to another, these solids will have a fixed shape for them. Generally, solids cannot be compressed. They cannot be compressed. They have rigid shape. A solid does not flow. Yes, solids cannot flow from one place to another place. They will be in the same place until and unless you apply some force on them. So, solids have rigid shape. They cannot flow. They have fixed volume and fixed shape also. A solid expands very little on being heated. Yes, solids won't expand actually. Even if you heat strongly, certain solids like metal rods and these all, they expand a little. The expansion is very less for solids. Solids have very less interparticular spaces and very high interparticle attractions. Here, two words, new words are here. Interparticle spaces means the space between the adjacent particles in the matter are called interparticle spaces. And the attraction between these side by side particles is called interparticle attraction. The interparticle space in solids is very less because we told these particles are very close to each other. The place between the particles is very less, negligible space, whereas attraction is very high. They are tightly bound because of that. So interparticle attractions are much high, whereas interparticle spaces are negligible or very less in case of solids. So this is about solids. They have fixed shape and volume. They are rigid. They cannot move. That means they cannot flow. They won't expand much when heated. And the interparticle spaces are very less. And interparticle attractions are very high in case of solids. Next about liquids, let us see. Liquids. In liquids, the molecules are not packed as closely as in solids. They are closed in liquids also, but they are not much closed as such like solids. They have some freeness. The molecules are have some flexibility to move one another, but they are not much tightly packed such like in solids. They have little loose packness or attractions. So the attractions are somewhat less when compared to solids. See different kinds of liquids. Example they have given. Water is a liquid. Some fruit juices are liquids. We can say some other examples also for the liquid sugar. What are those? Yes, oils will come under liquids. Petrol, diesel, kerosene. These all will come under liquids. What are the general properties for these liquids? Let us see. A liquid has no fixed shape. It takes the shape of its container. Yes, as solids have fixed shape, but liquids do not have any fixed shape. They will take the shape of the container in which they are poured. If you take water in a glass, the water will acquire the shape of the glass. If you pour the same water into a bowl, the water will take the shape of that bowl. So the water liquids do not have any fixed shape. They take the shape of container. A liquid can be compressed only to a small extent. Yes, actually solids cannot be compressed, but liquids can be compressed a little. A small quantity of volume can be raised by applying high pressure on the liquids. So they can be compressed to a small extent. Liquids can flow. Yes, we know that. If you take one glass of water, you pour the water on the floor. What happens? Will be in the glass formula there also? Water? No, it will flow from one place to another place. But liquids can flow only in one direction. What is the direction, children? They can flow from higher altitudes to lower altitudes. Why they can flow? Because molecules are loosely packed, they can slide one another. So the particles they will slide one another, hence they can flow. A liquid expands or contracts more than a solid. Yes, a liquid can be compressed or can be extended or expanded by heating to a little extent which is greater than that of the in solids. Liquids have more interparticle spaces and less interparticle attractions when compared to solids. Yes, the space between side by side particles is a little greater when compared to that of in solids. So in solids, molecules are tightly bound, but in case of liquids, there will be small gaps between the molecules or particles. That is why they are able to move. So the spaces are somewhat greater and attraction somewhat less. In solids, what happened? All the molecules are tightly bound. But in case of liquids, there is some movement or flexibility for the particles. So attractions or friendship is somewhat less when compared to solids. Spaces are less and attractions are much. Spaces are more and attractions are less in case of liquids when compared with solids. Next about gases. In gases, the molecules are at a greater distance from one another as compared to solids and liquids. Yes, that the places between the gases, particles are very high when compared to liquids and solids, and the attractions are very negligible. That means the friendship or attraction between the molecules and gases are very less or negligible. Because of this reason, they can move there and here very freely. Molecules are having very freedom, much freedom in gases. If one molecule is here, one molecule is somewhere else, one molecule is somewhere else. There is no attraction relation between the molecules in gases. They can move in any direction. So here you can see these balloons are filled with gases. Now, what are the general properties for these gases based upon the arrangement of molecules? Let us see those. General properties of gases. So a gas has neither a fixed volume nor a fixed shape. So when we say about solids, they have fixed shape and fixed volume. When we say about liquids, they have fixed volume but no shape. They take the shape of containers. And by coming to gases, they have no fixed shape, no fixed volume. The volume and shape are assumed to be the volume and shape of that container in which these gases are kept. The complete volume will be taken by these gases, and even the shape also will be taken by the gases in which they are preserved. Next, gases can be compressed to a much larger extent than solids and liquids. Yes, gases can be nicely compressed to large extent. How much large extent means the gas which is there in the entire room can be stored in a small bottle. Very fine example for this is the scent bottle or perfume bottle, which is containing large quantity of air, which is compressed and stored in a small bottle. One more fine example and very well-known example is the gas stored in the LPG or domestic household gas cylinders. In that, a large quantity of gas is there, but it is stored in a small cylinder. How does it be done? How it is done? By compressing that gas. Gases can be compressed to a large extent. Because of that, a large quantity of gas is compressed and kept in a stored in a small container. So compressibility is very much high for the gases when compared to liquids and solids. A gas expands to a greater extent on being heated. So how we told this compression exists for gases in large extent. This expansion also will be much for gases. Gases freely mix with one another. Yes, it is one of the special property for the gases which is not there for other one. That is a diffusion. They easily mix one with one another themselves. So this freely mixing of gases one into another is called diffusion. Intermixing of gases is called diffusion. Because of this diffusion property only, we told now once perfume or spray. If you spray this perfume or some deodorants at one place in the corner of the room, immediately the smell or fragrance of that perfume will be absorbed by the people who are there in the entire house. How it is happening? These perfume or scent gas molecules are spreading into the air immediately. They are mixing with other gas molecules. That is mixing property or spreading property is called diffusion. This is there for gases especially. Gases have very large interparticle spaces and negligible interparticle attractions. Yes, these spaces between the molecules are very high because there is no friendship at all. Attractions are negligible. Then the spaces are very much greater when compared to solids and liquids. Next, about the fourth state of matter, we told this is the new state we say. Fourth state of matter, new for us. In the lower classes, we might have heard about those three which we have learned till now: solids, liquids, and gases. This is completely the new state, which is called fourth state of matter, which is also called plasma state. As we told, plasma is the fourth state of matter. Plasma is similar to the gaseous state. Plasma is made by heating a gas. We know generally that interconversions. When solid is heated, it converts into liquid state. If we heat a liquid, it converts into gaseous state. This we know. If we heat a gas, what happens? This we might have learned earlier. If we heat a gas, it will be it will be very hot gas. If we heat continuously to very high temperatures, then those gas molecules and atoms and gas molecules present in that gas will be ionized. Means those gas atoms and molecules lose electrons and form ions, and electrons exist in the same position. That is called coexistence of these ions and electrons will be happening. So when these gases are heated very strongly, these atoms and molecules present in the gases will lose electrons and they form ions. So the coexistence of these ions and electrons together is called as plasma state. This can be obtained at very high temperatures. This will be obtained from the gases at a very high temperatures. See, this is one of the fine example for plasma state. These are suns and stars in the space. They are made up of this plasma. The plasma is produced in the sun and stars because of very high temperatures. We know these suns and stars are filled of one of the mostly they are filled of one gas. Do you know, children, what gas it is? Yes, it is hydrogen gas. Hydrogen gas is filled in sun and all the stars. This is continuously burning in that. So when this hydrogen gas is burnt and converting into helium gas, they produce a large amount of heat. Because of this large amount of heat, the other gas molecules present there will be losing their electrons and forming ions and electrons to coexist. That coexistence we are calling as plasma. So these stars and sun are the globes of plasma. Right? The sun and the stars glow because of the presence of this plasma in them. Yes, we say sun and stars will be brightly glowing. This is because of the existence of plasma in them at a very high temperature. Right? On the Earth, plasma is naturally occurring in flames, lightning, the northern and southern lights. Yes, on the Earth also, often we see this plasma. Say when lightning occurring, this high voltage current is produced from the clouds there. It comes to the Earth. So when it is in the power, the gas molecules which touching the high voltage current will be ionized for fractions of seconds. So their plasma is created. Because of that only, there you can say some glow, glitterness immediately happens. The brightness is because of formation of plasma for few seconds there. And even in the sky, we see some glow in the northern, southern corners. So that is because of this plasma production there. So this is about the fourth state of matter, that is called plasma. Next, Bose-Einstein condensate or BEC, which is called fifth state of matter. Bose-Einstein condensate. So we told when we heat a solid, it converts into liquid. If you heat liquid, converts into gases. If you heat these gases to very high temperatures, they convert into plasma state at very high temperatures. So what happens if we cool this in the reverse way? Then this Bose-Einstein condensate is formed, which is called BEC, the fifth state of matter. In 1924, Albert Einstein and Satyendranath Bose together predicted the Bose-Einstein condensate or BEC, which is referred to as the fifth state of matter. So with the since microscopes which we seen, it will be showing like this, fifth state of matter. A Bose-Einstein condensate is a gaseous superfluid phase formed by the atoms cooled to temperatures very near to absolute zero. You know, absolute zero means very low temperatures. So when gases are cooled to very low temperatures, they form a superfluid in which all the molecules will come to freezed state. No vibrations. Actually, in the gases, molecules will be continuously vibrating and moving there and here. When these gases are cooled to very low temperatures, that is nearly absolute zero temperature. What is absolute zero here, children? It is 0 Kelvin, which is also known as minus 273 degrees Celsius temperature. If you cool a gas to this temperature, all the molecules come to freezing position and forms a superfluid condition phase, that is called Bose-Einstein condensate or BEC. A Bose-Einstein condensate is a state of matter of a dilute gas of bosons cooled to a temperature very close to absolute zero. We told already what does it mean absolute zero means? It is minus 273 degrees Celsius temperature or 0 Kelvin. It is called absolute zero. If a gas is cooled to this temperature, it forms Bose-Einstein condensate. How it is formed? Under such conditions, a large fraction of the atoms collapse into lowest quantum state. Means all the molecules in atom, they lose energy. They will come to very lowest energy state where they cannot move at all. They will be freezed, and the volume is considered for that gas at the temperature almost zero. That state is called Bose-Einstein condensate. Right, children? That is about 5 states of matter. What are those? Solids, liquids, gases, and the two different states newly known plasma and Bose-Einstein in condensate. These are the five states of matter, right? Based upon this, you can see assessment now. The first question is, a few substances are arranged in the increasing order of force of attraction between their particles. Which one of the following represents a correct arrangement? So here they are going to use certain matter forms. We have to observe in which the correct arrangement is given in the increasing order of their force of attractions of particles. See options given: water, air, and wind. Air, sugar, and oil. Oxygen, water, and sugar. Salt, juice, and air. See, we know one thing: the interparticle attractions are much higher in case of solids, and they are somewhat less in case of liquids, and they are very least in case of gases. So they are asking increasing order of attraction between the particles. So first what you have to write, the state which is having lowest attractions or very low attractions between the particles, that is gaseous state. Next, second one, which are having low attractions, that is liquid state. Last, the state which is having the highest, the much greater attractions between the particles, that is solid state. So first gas should be there, then liquid, and then solid. In which option, in this order the matter is given, that will be correct option. Now you check them and you can give correct answer in the live chat. The correct option you can give. Yes, already some of you have given, very good. So what state of matter is this water? Liquid state. It is gaseous state. What about wind? Also a gaseous state. So liquids are having greater attractions than air. So this is not a correct order. We see air, it is a gas. What about sugar? It is solid. And what about oil? It is liquid. So are they in increasing order? No. Gases are having much attractive uh, force of attraction, less of course, and sugars are having much attractions than oil. The reverse order is there. So it is wrong. If you see third option, oxygen, water, and sugar. Oxygen is a, as we know, it is a gas, whereas water is a liquid, and sugar is a solid. Now, if you observe the attractions, as we know, gases are having less attractions than liquids. Liquids are having less attractions than solids. So this is a correct increasing order. What about the third one? Salts, solids, they have been starting. Juice, liquid, air, gas. What is the order of attractions here, children? Salts have greater attractions and juice are having greater attractions than air. This is decreasing order. So the correct increasing order of force of attractions is given in third option. So C is, yeah, most of you have given correct answer. C is the correct answer. So this is correct increasing order. First gas, then liquid, and solid. Fine. Next, the property to flow is unique to fluids. So the flowing nature is called fluidity, and those which can flow are called fluids. Which one of the following statements is correct? Only gases behave like fluids. Gases and solids behave like fluids. Gases and liquids behave like fluids. Only liquids are fluids. Which is correct answer, children, here? Which can flow? Yes, the state of matter in which particles are having loose packing between them can flow. They can slide their particles one another and hence they can flow. In which states particles are loosely packed? In liquids and gases. These two states, in these two states, matter can flow. But in liquid states, matter can flow only from higher altitudes to lower altitudes. But in gaseous states, matter can flow in all directions. So, what is the correct answer here? Gases and liquids behave like fluids. Did you give the correct answer? Yeah, many of you have given correct. Very good. Nice. So, third one is correct answer. Next, it is a third question. In which state are the distances between the particles are greatest? So, in which state distances are being greatest? Means in which state molecules are far away from each other. Yeah, some of you have started giving answer without options. Very good. Gas, liquid, solid, and both liquids and solids. Which is correct answer, children? In which state the distances are greatest between the particles? Yes, it is. Right. Good. It is A. Gases. In gases, the distance between the particles are greatest when compared to solids and liquids. Next one, yeah, here the particles of gas we can see. The distances are much higher between the particles. They can move randomly in any direction because attractions are very less between them. Good. Next question. Which of the following is a property of gases? So here they are going to give some properties. Identify among these properties which belong to gases. They have no rigidity, means they are not strong. They can diffuse, means they can easily spread in the air. They have definite mass. All of these properties. Are the gases having fixed mass? Are they having definite mass? Yes. So we say some properties like shape and volume. Shape and volume are not fixed for gases. They take the shape and volume of the container in which they are preserved. But always gases also having fixed mass just like the solids and liquids. So the solid gases are having fixed mass. They can be diffused and they don't have any rigidity. Means they can be compressed very easily. They are not strong enough. So these three statements are correct related to gases. Now what will be correct answer, children? Yes, it is all of these. The three statements are related to gases only. Next, certain substances exist in the solid state because. Why they exist in solid state? Some substances, see reasons given here. Intermolecular forces are weak. That is why they are existing as solids. Molecules can slide one another. They can slide one another easily. Is it the reason for being solids? Molecules are tightly packed. Is it reason? Molecular motion is very fast. So which is the correct reason to be a solid? Yes. Yes. Good. It is correct answer. Between the molecules of solids, their attractions are very high, so they are tightly packed. Because of this reason, they exist in a solid form. C is a correct answer. Next question is given based upon the pictures. A student poured an equal amount of water into 4 containers as shown below. What result does this experiment show? See, same quantity of water is taken and it is poured in different containers. One is a conical flask, other one is called beaker. If you see, one is a measuring jar and one more bowl. In these all same quantity of water is poured. Now they are asking from this observation what conclusion you can give. What is the result from this experiment they are asking? See options. Water has definite volume. Water has no definite shape. Water has definite mass. Water has no definite volume. So what is the correct result from this experiment? What is it, children? Yes. Yes, it is. Water has no definite shape. Yes, it is correct option because if you see in the question itself they have given equal amount of water is taken. Then there is no question of volume again because same quantity of water is taken already. So they are already having different mass. So here what we observe in different containers, water is taking different shapes. Water is taking or liquid is taking the shape of the container. From this you can say those liquids like water, they do not have any fixed shape for them. So that is clear from this experiment. That is the result of this experiment. Okay children, thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. If you subscribe our channel, then you can get the updates about our upcoming live sessions. So to your directly your mobile will get some updates regarding this. Some notification will get, yes, there is certain class after this time. At particular time we are going to have this online class. In that way, you will be getting some notifications. Then you need not to ask anybody about the schedules of these live classes. If you subscribe once, you will get notifications about this all. If you miss any classes, if you miss any live sessions, then you can watch those recorded and uploaded videos in our YouTube channel, Aims Today. Okay, Juna? Thank you. Have a good day.